Okay, so today we are doing quideo 2. So this is the basic question, and it says, here are Professor Moore's times to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool. So they go ahead and give us the time and the pulse. And what you want to do is use your calculator to put these times into, you go to stat edit, and you want to put these times into L1 and L2. So X is time and Y is the pulse. And then you go back to stat edit. Make sure your diagnostics are on. So calc, and you want to go to 8, which is linreg A plus BX. So once you click enter, and then a couple times, you get all of these values. And the question is, verify the that the linear model properly models the data, and the equation. So what you would do is you look at the R value, and it's 7, which is a strong linear fit. It is negative 7.73234. Okay, and all the rest of those numbers, but it's an absolute value, so that doesn't matter. So yes, it is a strong linear fit. So the second part is to state the equation of the linear model, and this is our equation right here, and this X is time, X is time, and Y is the pulse rate. So it's Y equals 470.9537 plus and then the negative 943x. And then, so once again, X is time and Y is your pulse rate. So part B, part B says to predict, it says the next day's time is 34.30 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. How accurate was your prediction? So what you want to do is plug in time for X, so that the time was 43.0284, and what you do is once you plug it in, you get 147.2989. The actual was 152, so our predicted value was close enough and not too far off from the actual value. Moving on to part C, with least squares regression line. Yep, I said that right. You are always looking for Y in terms of X and never X in terms of Y. So we want to ultimately plug X in to get the Y. To do this, you need to move the equation around a little. So you want to use your calculator again, and then go to calc stat, and then you would do L1 comma L2. What this would do is it would flip the Y and X values, and it will give you a whole new set of data, which we have right here. We have a new A and B value. Y is now going to be representative of the time value, and X is going to be representative of the pulse value. So after you do that, you get this equation. So it's 43.02, and then plus the negative 0.56836 times the 152, which, as you can say, was the pulse rate that they gave us. And then once you do that, you get 34.389. So now we know that the actual is 33.4, which is even closer. So my prediction is 0.89 minutes above the actual time of 34.3 minutes. So it is rather accurate. Part D says to explain. Sorry, I lost my sheet. Okay, I found it. So it says, explain clearly to someone who knows no statistics. Why does there need to be two different regression lines for part A and part C? And so the least squares regression line is used to predict a y value given an x value. So to predict two different types of values, you must have two different lines. So the line for part A gives out a pulse rate when given a time, whereas line for part C gives out a time when given a pulse rate. And that's it for the basic question.